Okay, so today we're looking at what a rate of change is. You're going to see this word a lot in this chapter. Does anyone want to guess what they think rate of change might mean? It is the ratio of the change in the dependent variable. Whenever you graph independent and dependent, where is dependent always graphed? On X or Y? Dependent is always write this down somewhere, is always graphed on the y-axis, and independent is always graphed on the x-axis. So what do our two axes look like? Is x horizontal or vertical? Horizontal. Okay, this way. And y is always vertical. So you're looking at a ratio of the change in the dependent variable. So that would represent the rise. I want you to copy this down. The rise, which is the change in the dependent variable, how that changes, what does it go up or down by, over the run. It's called the run. Okay, so we're gonna talk about this more, but rate of change is equal to rise over run. That represents a ratio. Remember, we can represent ratios as fractions. It's basically just a ratio. The rise, whatever this is going up by, you're going to measure it with a ruler, over the run, so the horizontal distance. So all you're doing right now is you're just measuring the rise in centimeters. Okay, I want you to tell me what the rise is in centimeters, and then you're measuring the run, so the horizontal distance in centimeters with your ruler. So most of you got 1.7 for the rise. And what do we get for the run, the horizontal distance?
6.9.
Yep. 6.6. Okay, 6.6. What you're finding here is called the slope. You're calculating what the slope is. So slope is equal to rise over run. And in this question, it is equal to rise is 1.7 over 6.6. Okay? Now, I want you to write this as a decimal. So let's divide it. What is 1.7 divided by 6.6? What do you get? Okay, we're going to round it off to approximately. So we're rounding it. So I'm putting this little symbol here. Approximately equal to 0.254. Okay? Next example, which part is the rise? Vertical or horizontal? What's the rise? Vertical or horizontal? Vertical. Okay, so this represents the rise. What is the rise?
3.4.
Okay, I got 3.5 centimeters.
So it's gonna be
And the run
4.5.
is the horizontal 4.5. That's what I got as well. So we would say that slope is equal to rise over run. In this case, it would be 3.5 over 4.5, which is equal to what? I want it rounded to 3 decimal places so we can compare all of them. Yep. 0.777. We rounded it off, okay? All right.
At the end, it's 0.0.
Yeah, so we'll round it off to 0.778 because it's 0.7 repeating, but we'll round it off to 0.778. We're looking for the rise. Is that vertical or horizontal? Vertical. Asta, what's the rise? 1.6, okay, centimeters. And the run from here to here, so you're measuring from here to here. What did you get? 6.7. So again, slope equals rise over run, which is equal to 1.6 over 6.7, which is equal to what? We'll round it off to approximately equal to 0.239. Okay, so in diagram A, the rate of change was 0.254, B, the rate of change was 0.778, and C, the rate of change was 0.239. We need to order them from least to greatest. So, which one had the smallest slope? C, and then A, and then good. Now, I want you to think about how these ratios, these are the ratios, how are they related to steepness? What does this word mean? Steepness. What does the word steepness mean? Think about going skiing. Okay, so back to my drawing about
weird.
skiing. Hold on. If you're not a good skier, you're most likely going to choose which hill to go skiing on.
I'll go on letter B. This is
1 or 2?
2.
Because it's less steep. So what is the definition of steepness? Steepness refers to the slope of the line. And to find the slope of the line, you would find the rise over the run. You would find the ratio of the rise over run. So think about, how is steepness related to the ratio? Go back and look at your photos. Did you notice a relationship between the number and the steepness of the line? I'll give you a hint. The greater the ratio, what did you notice about the line? There's your hint. Let me write this down. The greater the ratio, so if the ratio was higher, if the slope was a larger number, what was the greatest ratio? B? What do you notice about that line? Is it steeper or is it less steep? So the steeper the line, if you go back to B, it looked like it had the steepest slope. And our ratios, when you calculate it, that number is the largest. Okay? So what we're trying to do here is we're trying to calculate the rate of change, which is equal to what? Rise over. Now, again, the rise is the vertical distance. So we can draw a triangle like they showed you in the other example. I can draw a triangle from here to here. You can pick any 2 points to draw a triangle, or you can draw a triangle from here to here, for example, and calculate the rise over the run. Doesn't matter where I draw my triangle in this example. It does not matter which 2 points you choose, because when you reduce your answer, it's a ratio, it's a fraction. When you reduce it into lowest terms, you're always going to get the same answer if the relationship is linear, and I like that word you used. If it's a straight line, your change in variables will always be the same. You're going up or down by the same amount every single time. It's linear. Yep. Okay, so let's look here. The distance from here to here, in example A, what is the rise of A? What is the rise from here to here? We don't need a ruler, we're going to use the graph. What does this go up by? Yes, 200. Excellent. What is the run from here to here? I picked this point. 4. The run is 4. Okay, let's reduce that. What's 200 divided by 4? Yes. Now, I made a mistake. I didn't actually point this out. Is this going up or down? Is the line going up or down? It's negative. It should have been a rise of negative, sorry. So when you take a negative and you divide it by a positive, what's the answer? Negative. Does that make sense for the graph? We would say the slope here is negative 50. You can write it as negative 50 over 1 or just negative 50. The slope is negative 50, right? Let's try point B. Let's see if we get the same answer when we reduce it. Now you have to be careful with, you have to look at the scale. From here to here, what does it go down by? We're going from 150 to 100. What is the vertical change? It's going down by what?
By 50.
By 50. Negative 50. And what is the horizontal change? From here to here. Look at your scale. From 1 to 2, what does that increase by? From 1 to 2. What's the horizontal distance? From 1 to 2. What's the change from 1 to 2? What are you counting by? 1. So negative 50 divided by 1 is negative 50. Did we get a different slope? No, because it's a straight line. You're going to get the same slope every single time you calculate it. It doesn't matter which 2 points you choose if it's a straight line. So if I asked you to calculate the slope of this line, you can pick any 2 points on the line and just calculate the rise over the run. Does that make sense?
Yes.